In this video we are going to discuss a very important concept in transaction is known as deadlock. Suppose an example is given. T1, T2 are two transaction. T1 issues read log on item Y and it read the item, and the two transactions are interleaved transaction. So T2 at the same time issues read log on X and it read the item X. Now on the time being, T1 needs to issue write log on X. So we know as there is issued read log on X by transaction T2, T1 cannot apply write log on X, and at the same time T2 want to issue write log on Y. As read log is issued on Y by transaction T1, so T2 will not able to issue write log on Y. So what is the case? T1 is wait for X so that T2 is released its read log on X and it can able to issue, transaction T1 can able to issue write log on X, and as well as T2 is wait or looking for Y so that T1 is release its read log on Y and T2 can able to issue write log on X. So this is a deadlock scenario. No one transaction will proceed or can proceed, and this is a wait for graph for the above schedule. If the wait for graph formed a cycle, then this will a deadlock situation. So this graph is known as wait for graph. So we will see how we can prevent, or the algorithm or protocols are there for prevention of deadlock. So we will see a new term known as timestamp of a transaction. So what is timestamp? Timestamp is an unique identifier, okay, assigned to each transaction. Timestamp is a unique identifier assigned to each transaction. Suppose this is timestamp of transaction T1, we can write TS means timestamp of transaction T1. Suppose another transaction T2, timestamp of transaction T2. So timestamp of transaction T1 is less than timestamp of transaction T2. What is the meaning of that? That means T1 starts before transaction T1. So T1 starts before transaction T2. So what is timestamp? Timestamp is unique identifier. It is given to each transaction. The timestamps are typically based on the order in which transactions are started. So if transaction T1 starts before transaction T2, then timestamp of transaction T1 is less than timestamp of transaction T2. So older transaction has smaller timestamp value. Okay. So suppose we will see the deadlock prevention algorithm wait die and wound wait transaction. Two schemes that prevent deadlock are called wait die and wound wait. Suppose the transaction Ti tries to lock an item X but unable to do it because X is locked by some older or some other transaction Tj. So with conflicting lock. So then in this scenario, what is wait die and wound wait algorithm? So wait die algorithm says if TS মানে timestamp of transaction T1 Ti is less than timestamp of transaction Tj. What is the meaning of that? That means Ti is older than Tj. Okay. If this condition valid, then according to this algorithm, Ti is allowed to wait. Otherwise else part, what is that? In else part, otherwise Ti is younger than Tj. Okay. Abort Ti, that means Ti dies. So what is wait die algorithm? Wait die algorithm is that if timestamp of Ti is less than timestamp of Tj, in that case Ti is older transaction than Tj, then Ti allowed to wait. Okay. Otherwise, in else part Ti is younger than Tj. Abort Ti, that means Ti dies and restart it later thus with the same timestamp. This is wait die. So otherwise Ti wait or Ti dies. So this is called wait die algorithm. And another algorithm is known as wound wait algorithm. What is that? If timestamp of Ti is less than timestamp of Tj, that means Ti is older than Tj, then abort Tj. So in that case we abort the younger transaction, abort Tj. So here Ti wounds Tj and restart it later with the same timestamp. Otherwise means in else part Ti is older than Tj, in else part Ti is younger than Tj, in else part Ti is allowed to wait. Okay, so this is known as wound wait algorithm. So this is one of the famous algorithm for deadlock prevention.